When embarking on a drawing of an interior space in one-point perspective, before drawing any details, you want to construct the planes and edges of the interior space. First, you want to position yourself. If you're working from a camera, position yourself in the camera directly across from a back-facing wall. If you're drawing from life, you want to position yourself at a place across from the back-facing wall where you're looking head-on across the space and not facing a corner. Okay? So the first thing you want to do is ignore all of the furniture and any of the fixtures. And you want to look at the shape of the back-facing wall. In this example, the shape of the back-facing wall, it's really a compound shape, right? So it's a rectangle here plus a triangle on top, which creates this compound shape right here. The best way to start when you're looking at a compound shape is to start off with the simplest shape of the compound, which in this case would be a rectangle. Okay. So observing the back-facing wall, think about what you see. In most cases, you're going to see just a rectangle, but in quite a few homes, if you're in a living room, not just a bedroom, you're going to see some other shape that is part of a compound. So isolate the most obvious shape of the compound, and there's a technique called siding and aligning where you can use a siding stick to measure the height of the rectangular shape that you observe. You put the tip at the horizontal alignment that lies along the top of the rectangle, and put your thumb to mark the distance on your gauge where you see the bottom. Okay, and then you're going to compare that distance to the distance of the width, right? So the width is a little less than 2 units bigger than the height. So then when you go to draw that initial guideline, the proportions of that back-facing rectangle part of the compound on your drawing paper, you know to make the height, right? You start off with any height in terms of scale that you want, but the width is going to be a little less than 2 times that height. Okay, so this distance here is the width is going to be a little less than 2 of these height distances. Okay. The next thing you're going to do is observe the second part of the compound that makes the back-facing wall. So in this case, it's a triangle. What we want to do is find the height from the base to the apex of the triangle. So we're going to take a unit of measure of the height of the back-facing rectangle, and we're going to compare it to the height of the triangle that is part of the compound of the total shape. Okay, it's a little less than 1 unit. So when you go to draw that, you know that you can take this measurement from your drawing and place it up here, and you can just subtract a little less from it and make a point, and then you just draw your slope from the point to the apex of the rectangle. So you're basically just mimicking this shape that you see on your drawing, but you're not just guessing at the distances. You're using a gauge, a process of siding and aligning to measure and compare distances, right? So the next thing you want to do, you see these, in every house, there's going to be an edge where the plane of the roof and the plane of the wall meet, that edge, right, on both sides. And in this case, there's a piece of wood here with 2 edges that the edge of this detail lines up against the plane of this ceiling. Okay. So you're going to take your sighting stick and you're going to take a slope alignment and align it along that stick. And then just observe the angle, right? So it's not horizontal and it's not vertical. It's at some slope, right? And so you're going to translate that slope to your paper. And you'll do the same thing with the right side and translate that slope to your paper. And then I see I can observe 2 more slopes. 1, 2. And then look at what happens. All of these lines that are horizontal and parallel in the real space, in perceived space, they all converge on a vanishing point. This vanishing point, we know from the rules of perspective, lies along a horizon line, right? The vanishing point is always located on the horizon line, right? So we know that this is a horizon line here, even though I haven't drawn a line, it's invisible. We also know from the rules of perspective that once you know where the vanishing point is, then the other slopes of the room, the floor where the plane of the wall meets the plane of the floor, there's going to be an edge. And so we can use the rules of perspective to align our stick along the vanishing point, intersecting the bottom apex, and then that line we can use to create, that slope is what will create this edge right here. And we do the same thing on the right side. Okay, and then you can erase on your drawing the excess. I like to bisect my shape. So this is a very simple compound shape back here, this triangle on top of the rectangle. And if you just draw a center line right down the middle, and then that gives us the ability to bisect the right half from the left half. Right? And then that gives us a couple of guidelines to work from. So if you look at the details now, we've already drawn the big shapes and planes. Now we want to draw the smaller shapes of the details within the back-facing plane. Okay, by drawing that center line on your paper, you can see that that center line correlates with the center of these of these doors and the cable of this lamp, right? And then everything on the right is going to be symmetrical with everything on the left. So you're observing the behavior of these shape relationships, basically, of the details that you see on the back wall. Now, I am taking another unit of measure of half the distance of the primary rectangle, and I'm going to compare that to the height of where this bottom row of windows right here starts, right? And so then I know where to put this horizontal collection of windows. And then I just go ahead and make a rectangle, and then I can split that into 3. So what I'm doing now is I can observe that this space, the details on this space back here, are kind of split into thirds. And so I'm just going to double check. I'm going to sight the middle and sight the right edge and the left edge details, and I can see that the details on the back facing wall in this example are split into thirds, right? And then I can start creating and mapping in those details that I see, right? So I see a larger rectangle of compound shapes in the middle, and sketch in the compound shapes that are within the back-facing plane. Okay. Mapping in all those details first gives us a lot of areas, landmarks that we can compare everything else to. Okay, so the most important thing when you're sketching in one-point perspective an interior space is to capture the compound shape of the back wall, and then map in all the details of the stuff that you see that you can observe that are on the back wall. The next thing I want to do is map in this table, right? So I can see that the table is below the horizon line and located below the doors, but I don't know how far below to put it, right? So I can I can observe it and kind of guesstimate it, or I can take a unit of measure. So in this case, I know the back wall is split into thirds. I'm going to take a unit of measure of 1/3 of the back wall and compare it to the bottom edge of the back facing wall where the floor meets the back facing wall, and I'm going to compare it to the distance, how far below that edge this table starts, right? And I can see that it starts about the same, 1/3 down. And then I'm going to make a vertical alignment to see where the point of this table starts along the details that I have drawn up here. So I can see that if I look at the back facing wall, I can see all the way down these details. If I keep going down right on that line, this point is in, a vertical alignment with all of these details. So I'm going to make another vertical alignment on the left side, and then I know from the rules of perspective that everything that's in that space that is situated, square to the walls and the floor in that space are going to line up with this 1-point perspective. Now, if this table were twisted, rotated, or twisted to the left or to the right, it would have a 2-point perspective. But in this example, this table is situated in a 1-point perspective circumstance. Okay, so I know if I line my sighting stick up with the point in the corner of the table on the left, you can see how the edge of the table, right, is aligned with that slope. And the same thing on the right side, and then get rid of the excess. And then I'm just taking a unit of measure. The most convenient unit of measure in this example is the small window at the top, and comparing it to the distance between the edge of the back wall and the back edge of the table. It's not very far. It's a little less than this distance here. But that just gives me a more accurate placement of my edges when I'm comparing their location to the distances that are existing in other shapes and edges on the paper, right? And then I'm doing another vertical alignment to see where the edge of this detail down here is lining up with the back facing wall in a vertical alignment. Same thing on the right side. And then I'm using that unit of measure again to find the bottom edge of that rectangular prism underneath the transparent tabletop. Okay, so just go through this whole process. So any of the converging lines, which in the real space would be parallel to each other, they're all going to converge onto the vanishing points. And then any of the vertical lines that you see in the area are going to be just straight up and down vertical. Okay. So I'm just going to do this process of measuring what's already there to find the distances of edges that I can see, but rather than just randomly guessing where they go, I'm measuring where they are located in relationship to other items in the environment. Right. So I'm taking a series of vertical and horizontal alignments to make placements, and then just if you notice how I'm handling this couch, I'm drawing one edge of it, the front facing edge of it first, right? Then I can carve into that square and get that detail, erase the excess. But then look what happens. I have all of these vertices, right? And I know from the rules of perspective that I can use the vanishing point and line my sighting stick up along with the vanishing point intersecting each vertices to draw the top edge, front edge, all of these edges of the couch. And then we do the same thing on the left side. Right, so I'm just going a little fast here. You have this video, but you can also go through the slides a little bit slower. So I'm not just observing and drawing. I'm actually observing and doing a combination of observation and using this process of combining sighting and aligning with the rules of 1-point perspective to construct a more accurate mapping of the shapes and edges of what I'm observing in this space.